Hey team, welcome to the numbers game. I'm Coach T, and in this tutorial we'll be expressing trig functions as algebraic functions. Let's get started. So in our example here, we're given a trig function, which is cosecant of the inverse of cotangent of 5 over x, and we're asked to express this trig function as a purely algebraic function. So to successfully make this conversion, we're going to start inwards and work our way out. And to be clear, when I say let's start inwards, I mean let's evaluate our innermost trig expression first. And with that being said, our innermost trig expression is the inverse of cotangent of 5 over x. And because that whole piece is within cosecant, I'm going to set it equal to theta. So we have cosecant of theta, where theta equals the inverse of cotangent of 5 over x. Now note that the inverse of cotangent of 5 over x can be simplified to cotangent of theta equals 5 over x. So this is what we want, right? We want the trig expression to be on one side of the equal sign and our algebraic expression to be on the other side of the equal sign. So now at this point we can use SQRT. SQRT is going to be helpful here because it's going to allow us to take our trig expressions, right, cosecant and cotangent, and express them in terms of the sides of a right triangle, that is opposite, adjacent, and hypotenuse. Now the opposite, adjacent, and hypotenuse sides of a triangle are typically expressed as numbers or variables, so using SQRT is what's ultimately going to lead us to a purely algebraic function. So we've got cotangent of theta, which SQRT tells us is adjacent over opposite. And we also know that cotangent of theta in this case equals 5 over x. So for our right triangle, the side that's adjacent to theta equals 5, and the side opposite theta equals x. So we've tackled the inverse of cotangent of 5 over x, and now we'll take a look at cosecant. To use a bit of foresight here, note that cosecant of theta equals, according to SQRT, hypotenuse over opposite. So evaluating cotangent of theta gave us our adjacent and opposite sides, and to find cosecant we need our hypotenuse. And this will be easy because all we need to do is use Pythagorean theorem. As a quick recap, Pythagorean theorem says a squared plus b squared equals c squared. And the hypotenuse of a triangle is typically represented by c. So for us, we have x squared plus 5 squared equals c squared. We'll square root both sides, which ultimately gives us c equals the square root of x squared plus 25. Now that we have our hypotenuse, we see that the cosecant of theta, which again equals the hypotenuse over opposite, equals our hypotenuse, which equals the square root of x squared plus 25 over the side opposite of theta, which equals x. And there you have it. We've been able to express our trig function as a purely algebraic function. And I think this time I'm actually going to leave you guys with an example to do on your own. Here you are. Express this trig function as a purely algebraic function. And when you get your answer, drop it down in the comments below. I'll also leave the answer in the description box, but don't peek before you get your own answer. That would be cheating. If this video was helpful for you, give it a thumbs up. Like the video and subscribe to the channel for more math tutorials. I'm Coach T, and thanks for watching the numbers game.